welcome everyone to another one of the events that we do here at Flux. So this is something that we do basically every 2 weeks, and there's always a different topic. We bring in guests. In this case, Cornelius, who I'm going to introduce in a few minutes. But we've had a whole different guests from like Apple engineers, like hardware founders, sharing their experience. So in any case, if you guys have any topics that you'd like us to cover, or even specific people that you'd like to see invited and talking, feel free to either like unmute and share out with us, or put your comments in the chat. So if you have a specific topic or someone specifically that you'd like to hear from, that could be either from the Flux team, or in general, and topics, same thing. It could be either a specific electronics engineering topic or a Flux topic, if you would like to learn about that. So for the new people here, and maybe in case someone hasn't yet tried out Flux, so Flux is an online ECAD or PCB design tool, and we just went out of the sort of beta phase a week ago, and basically what that means is that we feel that the tool is now ready to be used by anybody, and we don't need to let people in. Just anybody can sign up and start using the tool. So Flux is fully browser based, and we're like big proposals of collaboration, meaning that we like people to share designs, we like people to share parts, and be able to work directly and collaborate directly on the design itself, and not have to share files via email, like people having different versions of the design and talking about different things. So yeah, that's what Flux is. If anybody has any questions specifically around Flux, feel free to again drop it in the chat or unmute, and we'll talk about that. So hey, Stephen, thanks for joining. Welcome. All right. So yeah, just by default, you're all, I think, muted. So if you want to say something or talk, you'll need to unmute just in case anybody wants to ask a question or share something. And
yeah, thanks.
They just start talking.
Yeah, just to add on,
No worries.
You're saying the collaboration aspect. Yeah, I was using Flux a little bit more this week, and to speak on the collaboration, it's never been easier for me to just pick off of somebody else's project and like build onto that or forget. Like, I feel like it's never been that intuitive or reusable. So.
Yeah, that's the whole point, right? So big companies do have kind of like a network of or a group of engineers that they can sort of help each other out. Individual designers or even like small teams, like for 1 or 2 people, they don't really have that luxury. So we're trying to expand and basically make like the whole Flux kind of like one big company where people can use each other's designs, parts, or even just ideas, right? Find something that you like, and then say, oh, this is interesting, I'm going to implement something similar. Hey, Soren. Yeah, yeah, we also have, I mean, this is browser based, and you have, you can add URLs to properties or even projects. Then you just click there and it will take you directly to datasheet. There's no need to open a different browser, go with different, use different tools. It's just there. So yeah, so for the event today, what we wanted to quickly cover is talk a little bit about certifications and pre-compliance testing, and mostly in the sort of context of IoT devices. So every different type of device or different industry will have slightly different testing requirements or compliance requirements. We're going to be talking about pre-compliance testing and what that means, what that is, why you should be thinking about that early in the development of your, if you intend to sell your device in any way. technically a device needs to be certified, even if you're selling 1 or 2 units. So if you're selling the device, it has to be certified. Of course, it's a lot more likely that someone's going to look at your company or device if you're selling thousands than if you're selling 1 or 2, but in any case. So yeah, we're going to be trying to cover sort of what certification is, and more specifically, what pre-compliance is and how that will help you sort of avoid pain down the line. And we're also, like in the second half, we're going to be talking about specific for IoT, what are the different tests or certification process that you might need to go through, and how you can basically, by choosing the right components or the right platform, you can save yourselves a whole bunch of testing, a whole bunch of problems that come cost and problems that go associated with doing more testing. So again, first half, we're going to be talking about pre-compliance. Second half, we're going to be talking specifically about IoT and what are the tests that you might need to do, and how you choose the right components to optimize and reduce the amount of testing, if you can, that you need to do. So to get started, I'm going to quickly share and why do I care about this? So I was in part of a company a few years back, and we had a device that basically was an industrial IoT device, so something that we were selling, and we had a version 1, so the first version that we started selling, and that was certified, was approved, all good. We sold a few tens of thousands of units. And then we decided to do kind of like a revision, so not a whole redesign, but a small revision of that hardware. And so when I joined the company, the second revision was basically almost done, and I had to go through the compliance process. And the designer of that board basically said, "Look, I didn't make any changes to any of the main components, so in terms of compliance, we should be fine with doing like a small set of tests." So we didn't do any pre-compliance test. We said, okay, it's fine. It's just a small update. So I'm not going to do any pre-compliance. I'm going to go straight for the final compliance test. And Cornelius is going to talk about what that means in a second. But compliance tests are orders of magnitude more expensive than pre-compliance ones. But we said, okay, let's save ourselves a bunch of dollars. So let's go straight for the compliance because we're confident that everything's going to go. And I'm going to quickly show you here kind of an example of what one of the changes was that we didn't even realize. So this device, sort of simplifying it, it was a main processor, and we had an antenna, like a UFL antenna module. And then on the PCB side, it was, I mean, again, simplifying, but it's very close to reality. We had the microprocessor, the RF path, and then a UFL antenna that looked almost exactly like this. One of the tests, also one of the changes that this PCB designer did was he just introduced a test pad in the antenna path, and how that looked on the PCB was almost exactly like this. So he added a via in the pad of the UFL connector, a very, very short trace, and a test pad. And it looked exactly like this. So you had the antenna, but on the other side of the board, you had a very tiny sort of a via and a very tiny trace with a test pad. And the idea for that was that he was trying to improve the way that we tested that device. So basically, he introduced a new test pad in the bottom, so we could basically put a bed of nails testing rig and test directly on that path. So it's seemingly a small, stupid change, but that change was enough to basically change the impedance and the shape of the antenna and introduce this sort of small RF stub, and that was enough for us to basically fail the final compliance certification. And this wasn't a really well-documented change. So when I was going through compliance, I actually had to fly to China where we were doing the compliance test. And I basically slept for 3 nights in the lab to try and figure out why, like all of a sudden, our Wi-Fi was failing certifications. So that's basically to show that a very small change can have a huge impact on the certification. And if we had run a pre-compliance test, we would have figured this out a lot in advance. And even before we actually manufactured the thing, we were so confident that we actually manufactured the thing. And then we started seeing that we failed the test. So like all the options at that point were bad, either, so Ari, I'm gonna explain just in a second what the failure actually was. But the other options from that point on were either to, so if we limited the amount of power that the antenna had, we could pass certification, but that will affect all our users because they will have less Wi-Fi performance. Or we had to, basically what we ended up doing was every single board, like 25,000 boards, went through a CNC, and we basically just cut this, basically from here, we just cut this bit, drilled it out, and that saved us. Well, saved us. We had to put 25,000 boards through a milling machine or CNC machine. And yeah, so the compliance failure was that our emissions, all the harmonics that we had, were above the limit at the same transmit power that we had before. So we either had to reduce the transmit power so that all the harmonics were below the limits, or the solution that we went for, which was basically cut all these things. It also affected the sensitivity of the device, which basically means how good the device is at detecting the Wi-Fi signal when there's noise in the environment. So those were the two sort of tests that we were failing. But failing one test means there's no certification, and that means there's no selling the device. So it's kind of a big deal. All right, so that's kind of like a quick story to show why you should care about certification and why you should specifically care about pre-compliance. And we have Cornelius here, who has a bunch of experience running pre-compliance tests. And she's gonna walk us through what a pre-compliance test is, what you should keep in mind, what are the things that you need, stuff like that. So Cornelius, if you wanna take over, introduce yourself, and sort of walk us through pre-compliance.
Sounds good. Thank you. Let me share my screen, obviously.
And while you do that, again, like as Ari was doing, feel free to drop your questions in the chat. And then at the end of Cornelius's part, we're going to ask those questions and make sure that they get answered.
Oh, no. Okay, I'm going to have to be right back, I guess, because Zoom is making me get out of it before I can share my screen. I apologize.
Yeah, no worries. We'll wait for you quickly. Yeah, so this was so that story was it basically cost us. I think we're paying $2.50 per piece, or $2 per piece for doing this CNC thingy. So it basically was a $50,000 mistake, because we had to, the whole batch of 25,000 boards, we had to sort of mill that small trace out. It had to be very precise, because if the mill like went a little bit too deep, we will be damaging the board. So yeah, it wasn't fun. Right, welcome back, Cornelius. I think you can turn your screen now, and remember that you're muted as soon as you join. So
Sorry about that. Nico, I think I need to have you
okay.
enable me to share my screen again.
Yep. There you go.
Okay, thank you. All right. There we go. Okay, so to introduce myself, my name is Cornelius Robinson. I've been working with the Flux guys for a while now, but previous to that, I worked at Schweitzer Engineering Laboratories, which is a it's a they do industrial electronics for the power grid. They are located here in the United States, and I worked for them about 7 years. I was a hardware engineering technician, so we did all sorts of pre-compliance testing and research and development, that sort of stuff. Some of the products that we had are, we have a computer that I helped develop, as well as a couple of these other ones as well. But yeah, these are all for control, for automation, for protection, for the power grid. A lot of times you'd find these products in a substation, if you will. Okay. And feel free to interrupt me if you have any questions. It's funny that, Nico, you mentioned going straight to compliance testing before pre-compliance testing, because there are several times throughout my career there that, managers want to save costs. We're fairly confident it's going to pass, shouldn't be a problem. We go straight to compliance testing and it fails immediately. And it's horrible every time. Not only that, it's expensive as well. So, like you said, compliance testing is expensive. It needs to be done by a third-party lab, and it becomes increasingly expensive if you have to do it twice. Most of your big companies can do these testing in-house, especially if it's a larger company like the one I worked at. There are many different types, and it depends on where you're going to be selling that product as well. The main one shown in the picture here is radiated emissions, which, Nico, I'm sure you're familiar with. Probably similar to the setup that you used for antenna.
Yep, same.
Yep. So that was actually a lot of fun to work in. We had some dedicated engineers running a lot of the equipment so that we didn't accidentally screw it up. But yeah, it was a lot of fun. In addition, we had radiated immunity, conducted emissions, ESD immunity, mag field immunity, surge immunity, electrical fast transients. A lot of those were also specific to the power grid as well. So within each of those within each of those tests, you have different standards that you can follow. And ours were a little bit more strict than your typical, not residential, but consumer electronics. And especially that you're selling around the world. So the United States, for example, is actually one of the least strict countries as far as these tests go, the standards that's required. I noticed that Europe, the EU, was actually one of the most strict, which was always a lot of fun. A lot of different standards there that we had to follow. And this goes back to the certifications. So like your CE certification, FCC for wireless, and then a bunch of other certifications that really just have a number attached to them. There's so many. That's probably the biggest pain point of doing any compliance testing or pre-compliance testing, is that you've really got to figure out exactly what tests or exactly what standards you want to meet and at what level. So it mostly depends on what standards you're trying to meet. Anyway. So why do you want to do pre-compliance testing? Well, I mentioned before, it's incredibly expensive to have to do it twice. And you don't want any surprises. So if you send a product off to a third-party lab to do pre-compliance testing and it doesn't pass, your options there are going to be either go out to that lab and essentially rent their time or their lab, their setup, to do troubleshooting there, or you get the product back and you can do troubleshooting at your own lab, which it just wastes a lot of time, a lot of energy, and a lot of money. So it's best to not have any surprises before you send it off for compliance testing, which means doing a whole suite of testing initially, so that you know exactly how the device is going to behave. So one of the tests that I frequently ran was ESD. I'm sure you guys are all familiar with what that is. There are, again, a variety of standards that go into the different types of ESD, or the different, not types of ESD, but the different levels that you want to meet for different applications, right? Like I mentioned that consumer applications are very different from industrial applications or military applications, that sort of thing. So typically your consumer level, you want to pass around 2 to 6 kV. And then your military and industrial is around 8 kV that you want to pass. And yeah, it's a lot of times what we did, we actually went way beyond that. So we'd go up to like 12 or 15 kV. And at those levels, things start to get really tricky because of the high voltage and the radiated field as well. So yeah, not only with ESD, it's a little tricky because not only are you dealing with direct contact, high voltage, but it also radiates because of how fast the rise time is. And so you run into a lot of issues where it's coupling onto traces, and yeah, it's a whole thing. So what do you do if it fails? Well, a failure really depends, again, on your requirements. So for us, it meant that the device couldn't reset. It couldn't halt its operation in any way whatsoever because, it's being used for protection on the power grid. It can't fail, essentially. So that's kind of what a failure looks like. And it's different it could be different for consumer electronics as well. For example, as long as there's no permanent damage to the device, then oftentimes it'll pass ESD or other tests as well. It really depends on your requirement. But I have spent months troubleshooting just to try to figure out, what exactly what happens, when it fails. So there's a lot of different troubleshooting methods that you can do. One of the techniques that we used at Schweitzer Engineering Laboratories was the shielding method, really. So a lot of our time went into shielding from ESD. And we spent a lot of time doing that because not only does it help with ESD, for example, but it also helps with other tests like EFTB and radiated immunity, that sort of thing. We found that even the small, tiny holes in the chassis can cause a lot of issues. I mentioned the ESD rise time is really fast. It's in the order of picoseconds. So any kind of hole in your chassis can actually act as a slot antenna and radiate onto your PCB, couple to your traces, and interrupt all sorts of communication that way. So what we'll do is we take, copper tape or other, pieces of shielding and try to figure out exactly where that ESD is radiating and onto what circuits. There are also different methods. For example, you can take a short antenna loop, if you will, and by passing a voltage through that loop, you can kind of wave it across the PCB and figure out exactly where it's causing your issues. Now, that doesn't work all the time. Oops. Sorry about that. It doesn't work all the time, but it does work. And that's just another method of trying to figure out where exactly the problem is. The issue with ESD, for example, is it doesn't always take the same path every single time. So you really need to run it multiple times in order to make sure that you've actually solved the issue. Speaking of solving the issue, a lot of times if you haven't been able to solve the problem by shielding, what you can do is take a look at the PCB layout. We can add protection diodes, for example. Sometimes if a ground plane is too close to a high speed communications line, the ESD from the ground plane and the chassis will actually couple onto those high speed communication lines. And so they need to be spaced farther apart in order to have some margin there so it doesn't couple. So there's lots of different factors that go into why it might be failing and how to fix it. Another way to do it is adding more protection circuits to the PCB. So, for example, a lot of times you are applying ESD to the various ports, like a USB port, for example. It's a very common one. And to fix any transients that get onto those communication lines, what you can do is you can add some ESD protection diodes to the traces there, and that will help prevent the communications from interrupting or getting back to the processor and blowing it up or what have you. So protection circuits are very vital for especially EMC tests, like the ones that I talked about before. Also, decoupling capacitors. So I know most of you are familiar with decoupling capacitors and why they're used, that sort of thing. But for EMC tests, it is really vital that the decoupling capacitors are as close to the protected part as possible, the ICs, so that it can absorb some of that transient voltage as well. So that helps a lot with that. But really, the whole point here is that you want to make sure that you've got all this stuff figured out well before you go to compliance testing, because again, it is expensive and time consuming. And the more testing you can do to characterize your circuit, the better off you'll be. With that, are there any questions? I think there was one in the chat.
Yeah, we have here where it says, does the issue with the ground plane also happen if the spike is clamped by an ESD diode?
It can, yes. ESD diodes are not foolproof. They do help. So it really depends. So for example, it depends on how high your voltage is, and what kind of, well, yeah, mostly how high your voltage is. But also it depends on your requirements for passing the test, right? So, you know, can you pass the test and have some functions be dropped for a minute? You know, communications, can they be dropped for a minute and then come back? Or is it that they just can't, you know, be damaged entirely? Or is the requirement that you can't have any drop whatsoever, no lack of function? So it really depends what your requirement is. But yeah, to answer your question, ESD diodes help, but sometimes the radiation from the ESD can still couple onto other traces.
Gotcha. This is another question here that I had on one-on-one is, so if I understand the question correctly, so what is the main difference between a pre-compliance test and a compliance test? Is that that you do that in the same, like in a different facility? I mean, I shared before also that usually they're done in different points of time. So pre-compliance is done before you manufacture the device. So if you need to fix something, then you still have time to fix it. But also, in my experience, it might be done in different facilities, which means and different equipment, which means that you don't need to potentially pay for a certified lab. You can do it in a smaller lab closer to you. What is your experience with that?
Yeah, so there are a number of third-party labs throughout the United States or the world, really, that offer compliance testing. Typically, you have to go to one of those unless some other special circumstances. At Schweitzer Engineering Laboratories, we actually had an on-site lab for official compliance testing, which saved us a lot of money. But it also costs a lot of money to be able to have that kind of a lab. Typically, what you want is for a device to be as close to the final product as possible when you're doing pre-compliance testing, so that, again, you don't have surprises when you actually go to compliance testing. As far as the different labs go, you really want to do pre-compliance testing right before then, and it's not official. You're not going to get signed off on it. It's just to see how the product is going to behave during those tests. That way, when you do the actual official testing, you can get signed off for it, and you can start selling a product in, whatever country, or, for example, the CE mark that's often required in the EU. You have to have that CE mark to sell, and that the testing for that is going to cost a lot of money to get it done by the lab that is already signed off on being able to run that test. I hope that answers the question.
Yep, I think it does. So Thor here also asks, well, you have no idea which standards you need to comply with the labs guide you. The answer is yes. I'm also going to share a few tips now in a few minutes about how you can deal with that, to at least have an idea of what you might need to comply with before you approach a lab or you approach the product. And this other question here from Mark says, have you seen home equipment for consumer level radiation compliance testing? What is the cost of something like that? I'd imagine is not nearly as controlled because there's the anechoic chamber, but you could get any insights.
Yeah, so home equipment or consumer level testing, it really depends. For example, wireless communications, like Nico had mentioned, you have to have it approved by the FCC in order for it to be sold. So yeah, and you have to go through all the testing. That anechoic chamber that that was in my picture in the slide, yes, that sort of testing is what you need to be able to for pre-compliance testing, but also compliance testing as well. For just general stuff, it really depends on the company. Some companies will want their devices heavily tested, make sure that absolutely nothing is going to go wrong. I think Apple is a really good example, just because they go through some extremely rigorous testing before they send out any kind of a product. And that's just because, you know, they want to make high quality products. Not all consumer products require a lot of testing. Like I said before, in the United States, it really doesn't require a whole lot just to sell a generic consumer level product. One of the things you do have to have if you're going to plug something into a wall, you've got to go through UL testing, which is fairly comprehensive. They pretty much destroy your product and to see where it fails in testing, but it's something that is required. So yeah, there are still some compliance that is required in consumer level electronics, but it's probably not as extensive as you might think. I've covered mostly industrial products, which is the standards are way higher.
Yeah, I can talk about the sort of consumer level now, use it as a segue, and sort of introduce what sort of an IoT device will likely go through, and try to answer some of the other questions. So I'm gonna share my screen now.
Oh yeah.
And okay, so as Cornelius was saying, so there's a bunch of different tests that almost every device will need to go through. So you have EMC or immunity tests. He was talking about EMI, right? Radiated, conducted. All that is fairly likely that you're going to need if your device has some sort of electronics inside. Safety tests, those more likely. And again, the depth on which you need to test will depend on your industry or the type of device, but you're likely going to have to go through some sort of safety testing. If you sell in the EU, some environmental testing, so ROS or REACH, which basically certifies that you're not using any dangerous materials or anything like that. And specifically for IoT, which is one of the most sort of misunderstood and potentially dangerous in terms of risk tests, which is radio. So this is for devices that have some sort of radio or called intentional emitters. For example, Bluetooth devices, Wi-Fi devices, LoRa, Sigfox, like all these type of cellular, GPS. Those things contain radios, and each different certification body, like FCC in the United States or CE in Europe, have specific rules for radio testing. In the FCC is called Part 15. The CE version is called RED, or Radio Equipment Directive. And this is, again, like one of the most dangerous in terms of risk, because it's the hardest one to fix, likely requiring like changing the antennas and doing some heavy testing and troubleshooting. But also is one of those that you can actually do something to prevent from even having to run most of these tests. And that you can do by basically choosing the right modules and platforms that that you use for your product. And that's kind of like the interesting part that I want to share now. And this is like, if you're using Flux, you're going to have templates for most of these different platforms. You're going to have modules and stuff like that. So here's basically kind of like a rundown of how do you choose the right module. I mean, this says that you're looking for Bluetooth connectivity or Wi-Fi connectivity, again, or cellular. How do you choose the right modules to not have problems or as many tests down the line? Because again, the difference between having to do a radio test and not having to do a radio test, it's basically an order of magnitude in terms of certification cost. You can go from $5,000 to $50,000 or $30,000 if you need to do radio test or not. You're gonna need a lot of help from the radio manufacturer. So yeah, if you can avoid it, you should, and we're gonna be talking about how you avoid it. So most geographies around the world, so there's two main sort of standards for IoT devices and radio in general and electronics. Again, one is the FCC in the US, and the other one is CE in Europe. And then most other countries, I say most because not all, but most other countries base their own directives in one of these two, right? So if you comply with FCC and CE, you're most likely good in a big chunk of the world. You might need to file some paperwork, but most likely you won't need to do more testing. So what I'm going to be saying here mostly applies to FCC and CE, but also since other countries base their certifications on one of these two, that also applies for most other countries. And it's the idea of using a certified module. And what that means is that the radio module that you use has already been certified. And that basically saves you from doing a whole bunch of testing. But there are a few things that you need to keep in mind when you're doing something like this. First, not every Wi-Fi module is certified. So for example, this is a certified module. If you see this chip, like NRF 5340, which is a very common Bluetooth chip, this is not certified. There are modules that are certified based on this chip, but if you use this chip on its own, or even if you base your design on their development kit, that is not certified. So you need to go through certification testing. So the first thing is make sure that when you try to use a certified module, that it is actually certified, and certified as a module. So something that can be put in another device and hold its certification. So how you do that is usually so either module certified, you're going to find some sort of certification documentation. So you're going to see that it has either the EU or FCC or IC, which is a Canadian one, document. And that means that usually that the device is certified. For example, if you, in this particular module, you will have a regulatory information data sheet, which basically tells you how that certification was done and if how does it apply. And this is also very important because having a pre-certified module is not a silver bullet. It's not that, oh, I have a pre-certified module, I'm good, I can do whatever I want with it. It's not really like that. You need to really look at at these data sheets to figure out how exactly it was certified and what the certification is for. So for example, this is a very, very common mistake that some sort of first-timers sort of stumble on, which is the antenna information. So when the manufacturer of the module certifies this module, they do with a few different antennas. So you need to use basically that same type of antenna and the same gain, the same maximum gain of the antenna that's defined here. If you use a different, for example, here it says they're all UFL antenna, so they're all with a UFL connector, right? If you use a PCD antenna or a chip antenna, like chip antenna is something like like this, which is basically embedded. You've seen that in several different modules. So this is a PCB antenna, this is a chip antenna, and a UFL connector is something different, where you basically can plug an external antenna too, right? So if you chose and you use this same module, but with this type of antenna, it might not be, the certification will probably not be valid. Same thing happens if, so you need to basically take a look at the type, and the type needs to match, not necessarily the connector, but the type of antenna that you use. And same thing again. So if you put a bigger antenna than the one that was used for certification, that certification is no longer valid. So this is something that, again, many people fail to understand, and that basically causes you to fail certification. Again, like if you go for pre-compliance, you're gonna find all these things out earlier, but still, like keep in mind these things before you move forward. And the other big one, specifically for IoT devices and stuff that I've experienced in the past, is what is called collocation. So here it says the transmitter module may not be collocated with any other transmitter antenna. So what that means, and again, like many IoT devices have probably potentially Bluetooth and Wi-Fi, and they have different modules for that. So what this sort of warning means is that this module was not tested to be put in the same place with another antenna, right? So if this is a Wi-Fi module and you put a Bluetooth module in the same board, this certification no longer applies. You need to redo it. So again, these type of modules can greatly reduce, basically, for example, if you use a pre-certified module with the right antenna and it doesn't have any other module, you basically remove all requirements for radio testing your device. You just need to do like one specific subset, which is like super simple one, and you avoid doing all the radio certification, which again costs a lot and takes a bunch of time. But if you fail to take a look at the small details, then you thought that, oh, it's all good, I don't need to do these certifications, but then you find out, oh, I actually had to, and you might be failing. So yeah, keep these things in mind when you go for this. And then the other, so basically answer the question that, so if a lab will teach you or show you what you need to comply and what not, most likely yes. They charge for that. So usually it's not something that's free. So they will charge you for like identifying what standards you need to comply with. So there are a few tips that you can use to try and at least roughly figure out what you might need to test, to understand how much this potentially will cost before you even decide to go for that module or for that product itself. So one is find if you have a direct competitor, so someone that has the same device, or any other manufacturer that manufactures the same device or something very close that uses the same radio potentially, and they will likely have an FCC ID or a CE ID, which is basically for the certification, each device gets kind of like a serial number or an ID for FCC. And if the device has been certified, you'll be able to find this ID somewhere, either in the documentation, in the printed in the device itself. So it has to be there somewhere. So if you find this ID, you can actually, oops, let me copy. So if you Google that ID, there's a bunch of websites, for example, FCC report or FCC ID.io. So if you go there, all the tests and the reports are there. So they're all public. They cannot hide them. So you can actually see every single test that they had to go through. And you see the report, the lab report. And that is true for basically every single device that has been certified on FCC. And you can use basically this as a base to understand what you might need. If a lab tells you, hey, you need all these bunch of tests, and then you go and check your competitors, you're like, oh, but they haven't done all this. And you can go back to the lab and say, hey, why do I need this test and this device didn't? And they might say, oh, no, but if you, so there's a lot of caveats. So if you don't need to exceed certain power, then you might save some tests. So some labs do not do a great job. So if you can do your own research, figure out what you need before you even talk to the lab, you're going to be in a much better place to understand if all the, like, basically what they're saying you is accurate, and if you can skip some tests and save some money, because these things add up. And like a super simple compliance test will be $2,000-$3,000, and a very complex one can be in the hundreds of thousands. So there's a huge difference between adding more tests and reducing them. So yeah, this is something that you should keep in mind. Same thing goes for example, if you're using a Raspberry Pi to base your product off, you can find the Raspberry Pi certification, understand what they have gone through. So you're like, if you're doing a device that is similar, you can take a look at Raspberry Pi certification. You're like, oh, like they did this test or that test. And another tip that it's been very useful for me in the past is you not only can see the report, but you can also see who did the certification for that specific customer, in this case, International Certification Corp or whatever. And it will say the address like of the lab and everything. So if you're going to be certifying something that is close to one of your competitors, you can go to that specific lab and say, hey, I want to certify the same thing or for my version of that product. And you're going to already know that these guys have experience testing that specific product. They already know what type of tests need to be run. So yeah, you not only can understand what type of test they went through, but also which lab they actually used. So this is specifically useful for, like, most of the cheapest labs are in China, and it's a bit difficult to communicate, but you can save quite a bunch of money by going to China. So if you can find a lab in China that has already certified a similar product, the conversation is much easier. You're like, hey, I want to certify this product. It's very similar to this other one. So 80% of the conversation is already solved. So that is something that you can also use, like all these little tips. So I see a bunch of questions in the chat. I'm going to try to say, isn't the rule of thumb, if it has a metal can, is certified? Yes, that is a rule of thumb, though. And as Scott says, yeah, but you're still responsible if the overall product is compliant. Yeah, exactly. So one of the requirements for a module to be certified is that it needs to be shielded. So if a product is certified, it is shielded. The other way around, not necessarily, but likely. So if it has a metal can, it's certified. Probably yes, but it's not for sure. If it has a metal can and some sort of FCC, some sort of ID printed, then yes, it is certified, and you can look for that ID and then find out what type of certification it has. And when it says you are still responsible if the overall product is compliant, I don't know exactly where that was said, but yeah, like the company is, at the end of the day, the manufacturer of the device or the seller of the device actually at the end of the day is responsible for that product being compliant. So you can say there are, like, these tips that I'm saying, they're all, of course, legal tips, and it's not avoiding anything. It's just like finding the right modules, the right parts to save yourself some tests. But if you're going to be selling something, at the end of the day, you will need to go through a certified lab to get your thing certified. You're just going to be saving tests. It's very unlikely that you can actually not certify at all or not test at all. and still be able to sell your device. It's like a very, very slim number of devices, and they have a ton of requirements for you to be able to sell something that doesn't need to go through any test at all. So what about PCB trace antenna like inverted F? It's the same thing that I was saying before. So the data sheet of the module will tell you exactly what type of antenna and the gain you can or cannot use. So if you just hear PCB dipole, so if you do a specific PCB dipole antenna, it also shares like what exactly is the type of antenna. You can search for it and find out if your antenna is the same or not. But yeah, if it is certified, so if the certification matches the type and the gain of the antenna that you're trying to use, you can use it. If it's not specifically mentioned, you can't. Or if the gain of your antenna is higher than the one that was certified, you can't. You can choose it. So going through the questions. So those compliance testing reports are not fun to write. I've never had to write one, but I imagine that they're not. That's basically what the people running the labs do. Usually when you certify something, thank God you're not the one doing that. They are the ones doing that. So
yeah, I've done a little bit of compliance testing as well, and yeah, it's not as fun.
Is there a large price difference between labs in Europe and China? Yes. So if the difference is bigger, the more number of tests you need to run and the more complex those are. Most like, and the reason is a lot of these tests require a lot of human time. That there's someone like a lab technician going, testing, changing the machine, or the lab's equipment's parameters, testing again, moving something, putting back in, changing the device, reconnecting something. There's a lot of labor, like manual labor, involved in these type of tests. Some of them are automated, many of them are not. So labor is way cheaper. I mean, it's now less cheap, but it is cheaper in China or in some other countries in Asia than it is in Europe. So that is most of the driver of that higher cost. I mean, the con is that usually if with Europe or even within the United States, they're likely speak your same language, so that helps. But if you do your own research, you find the right modules, you know what you're testing and stuff like that, it's easier to go to China, pay a lot less, and still get basically the same thing. There's no one certification that is better than another one. If the lab is certified by the FCC or by the European C Commission or whatever, there's no, I mean, a lab cannot provide a better certification. I think I went off for a second. Can you guys still hear me? Okay, gotcha. So I don't know if anybody has any other questions or a little bit over time. So I want to be respectful of other people's time. So you can either drop if you need to go. If someone has any question, I'm going to give you a few seconds to type in the chat or unmute and share your experience, ask a question. If I answer Wu's question, which one was that? Check. Have you seen this one? Have you seen home equipment for consumer level validation, compliance testing? What is the cost? Oh, the cost of something like that. Again, if I'm talking about like IoT devices in particular. If you can save yourself the radio testing for a full CE plus FCC compliance, you're roughly talking about around $5,000 to $8,000. If you need radio tests, if you need more safety tests or stuff like that, you can climb up to. Again, I'm talking in China mostly. That will be around $25,000. In Europe, something similar will be, it's usually like around 50% more expensive, depending on the lab you choose. That's roughly.
I was wondering if you could like get an SDR and an antenna and drive out to like a field in the middle of nowhere and just like gain some insight about your radiation profile, but not that it's like a comprehensive test at all, but nobody does that. It's just not worth it.
I mean, oh yeah. I mean, so, and that's kind of like the difference between pre-compliance and actual compliance test. So you can do that to get an idea of how your device is performing. That won't be useful for certifying your product, but you can get at least some sort of idea of how that is behaving. In some companies, and there's a lot of ways you can do that for the different tests, right? Cornelius was talking about ESD. You can buy an ESD gun and test yourself, right? And then you get, like, if you test it for a while, you know roughly how to test that. You can, like I ran this, it's not failing at all. So you're a lot more confident that if you haven't done anything, that device is going to be working. Same thing goes for like EMI. You can maybe buy a very small anechoic chamber, put your device there and test it. It's not going to be certified, but you're at least going to have some sort of idea if you're good enough or completely out of whack. So many companies do that. They have some basic in-house equipment. They run kind of like super pre-compliance test. And then when they say, okay, like this roughly works, they send it to an actual lab to do pre-compliance, and then they go to compliance. Or for example, it's easier to do relative tests, right? If you, the problem with most of these tests, and specifically radiation, is there's a lot of noise everywhere, right? That affects your measurement. But it's easier to say, okay, I have some, this is what we did with our device. We had a previous version and a new version. So doing relative tests is much easier because the noise is going to be the same, right? So I put the previous test, the previous board, I do a measurement, and then I put a new one, and then the difference will be a lot more accurate. And that helps you identify these type of things, or troubleshoot or debug. So
yeah, noise is.
Thank you.
No worries.
Sorry, noise is the biggest difference between your compliance and pre-compliance testing.
Yeah.
In official compliance testing, you have an environment where they have set it up so that it removes as much noise as possible. Yeah,
they have. I mean, these guys are certified because they have specific noise levels and grounding and shielding and all that. That's what costs, right? Like all the setup that they have, and the fact that there's someone coming to that lab every once in a while to check that everything's going well, things like that. So Jarwin says, I wonder how much compliance certification has Starlink Dish gone through. Yeah, I have no idea. But like, I have no idea how much space things, like things that go into space, what they need to go through. Like, I honestly have no idea. But if the thing, like for the antenna for the ground station, that's something that you can probably see and check which standards they need to go through. And if it is a kind of like a commercial device, most likely they're not going to have to go through like very crazy certification processes. Of course, they're going to have a ton of radio tests, but it's not something that you're like, oh, like that's unbelievable. For space things that go into space, I have no idea. we're probably gonna have a bunch of different requirements.
I've sent up I've done work for the CubeSat lab at Cal Poly, and they've if you operate in the ham bands, I don't remember going through any FCC certifications radio wise. It was more like showing that you could deorbit and stuff like that, which is interesting. Actually, I do remember you have to like register your frequency. You have to like register your satellite and everything, but I don't remember actually bringing it to any compliance testing facilities. So, but I'm sure if you're like Starlink, that's a different frequency band. That's a completely different set of rules. So.
Then Soren says, we did that in technical school, test and search for radiation with antenna and oscilloscope for noise. Yeah, that's what many of us do when we need to troubleshoot, which is basically with was called a near field antenna. So basically a loop that you put right next to the device and try to figure out where the emissions are coming from and stuff like that. All right, so we're over time and I don't see any other questions. So I think we're good to wrap it up. And yeah, thanks everybody for coming. Hope this has been useful. Before I close, I'd like to invite you guys. We have a Slack community, like a Flax Slack community that I'm pasting the link in the chat. So feel free to join. We have like all the Flax team is there. And either if you have questions, either about certifications, CMI, stuff like that, we'd be glad to help you out if you're planning to launch a product. And it's something that we'll really appreciate if you have specific topics that you'd like us to cover in future events, or again, people that you'd like to see interviewed or talking or do a presentation, do let us know. It's very useful for us to sort of plan events for the future. All right.
Thank you, Nico and Cornelia.
It.
Yeah. Thanks.
And thanks guys for joining. Have a good one.